Bom dia a todos. Antes de começar, eu gostaria de pedir para as pessoas que tiverem aparelho de celular que eu desligasse ou então colocasse no vibração, né? Bom, e queria também dizer a honrosa presença da nossa vice-reitora, professora Ana Lúcia Gazola, e do presidente do IAT, professor Ivan Domingues, que me deram a honrosa missão de apresentar a professora Vibeke Sorensen. A professora Vibeke Sorensen é professora da área de animação e artes digitais da University of Southern California. Ela é consultora sênior do San Diego Supercomputer Center, desenvolveu pesquisas na área de visualização e animação junto aos institutos e laboratórios do Caltech, de Princeton, e do Neuroscience Institute, em La Jolla, Califórnia, e também do Jet Propulsion Lab, da NASA. Ela participou da área de visualização das missões Galileu, Mars Rover e Mars Observer, da NASA. Foi consultora na área de animação e computação gráfica na Walt Disney Productions. Seus trabalhos transdisciplinares foram apresentados no Museu de Arte Moderna de Nova York, o famoso MoMA, no National Gallery of Art, em Washington, entre outros. Trabalhou com animação digital estereoscópica, Omnimax, tendo recebido vários prêmios internacionais e bolsas de pesquisa, entre eles o Prêmio Especial de Contribuição para a Arte de Animação, da ZIFA, em Los Angeles, e também a bolsa da Intel Corporation, para pesquisa aplicada na área de visualização em tempo real para difusão e broadcast. A partir de sua formação artística, a professora Sorensen empregou em suas pesquisas recursos laboratoriais de diversas instituições avançadas na área de visualização, cuja metodologia e resultados poderão, nessa oportunidade, ser compartilhados pelos pesquisadores da UFMG. Nós tivemos uma amostra há pouco, que seguramente nós teremos a mais bonita conferência do que o IAT vai promover. Então, é um prazer muito grande passar a palavra para a professora Vibeke Sorensen.
Thank you very much, and thank you for your invitation to come here. It's my first time to Brazil, and I'm really honored to be here, and to be here especially at such an auspicious time of the year at Easter, and share in the cultural celebrations. And I want to just share my appreciation for that. Thank you. Let's see. So I wanted just to start by asking the question, how do we know who we are, what we are, and where we are? When we are born, we struggle to understand our place in the universe. We use all of our senses to explore and interact with the dynamic and changing world, and connect our sense impressions into a coherent and understandable mental model that to some degree conforms to it. We use our minds and our bodies to do this. Both are necessary to living, to functioning and understanding who, what, and where we are, and to live in harmony with the world and the universe, including nature and other living things. That was a wake-up call. We explore the world, which is constantly changing, and seek connections between things to understand their relationships and our relationships to them. In the process, we discover boundaries, and in some cases we cross them, and in other cases we adapt to them. I'm a child of the 60s, maybe some of you also are. I traveled a great deal and went back and forth between the United States and Scandinavia and born in Denmark. I felt that I was a cultural misfit in both places because the assumptions you have about what's expected of you are different in each place. But I was in the 60s, in the United States during the 60s, and I was very influenced by the civil rights and anti-war movements. And all of my family and friends were involved with the protests and were activists. It was very important then to question authority, to challenge stereotypes, which I considered always to be wrong, through direct experience, to break down distinctions and boundaries and make connections. The news media left too many people out and distorted the truth. I felt it was urgent to create an alternative that was more democratic. I felt it was urgent to intervene in media and technology, to create alternatives, to redirect it, to make it more responsible and more humanistic. I wanted to celebrate the common humanity that exists between people. We had to do something before the technology destroyed more life, more of our collective cultural heritage, and more of the world. I still feel this way. As the video artist Namjoon Paik has said, the problem is not whether or not to use technology, which is progressing too quickly, but how to humanize it. Well, I played the violin, but I left the orchestra for Latin jazz because of the freedom and the imagination associated with it, as well as its democratic structure. So I have a background in music as well. As a student, I wanted to study everything. Probably some of you have the same problem. And I wanted to find a way to put everything together. I received an International Baccalaureate degree in mathematics and also an International Baccalaureate in English literature. You see, I had a problem deciding. My experience with science and art, including visual art, led me to architecture. I wanted both ways of knowing the world. And I wanted to find a field that put everything together. So over the past 25 years, I have tried to understand our place in the universe through art and science. Using a range of media and approaches, I have tried to create alternative uses of technology that extend the human spirit and catalyze creativity and communication. I have explored poetic associations between the body and the mind, looking for new ways of connecting the senses and the mind that foster freedom and imagination. Are the media becoming increasingly multimodal? Well, these are my notes. I realize it's becoming more note-like and less grammatical. I think that our media are becoming more multimodal, multisensory, and I think the reason why this is happening is that that's because that's what our minds do to communicate with the world. And our model of the world and what we're trying to communicate with comes from what we know, and what we know is the human body and our interaction with the physical space. So I try in my work to insert the whole human body somehow into the work, including the mind and the physical and the abstract, if you will, the mind and the body, foregrounding people and humanity. I try to integrate digital space into physical space, positioning the technological domain directly within the perceived physical domain. I want to connect the mind with the body, the mind with the body, reverse the trend of technology to prioritize the mind over the body and the machine over nature. I want to find ways to break down hierarchies emulated in the technology and articulated through the technology, and foster associative, lateral, or poetic thinking, and combining music and text and visual imagery. The network allows us to explore collective memory distributed over the internet, forming a kind of dynamic collective consciousness. And I want to use the technology, network technology, to explore multiculturalism and multidisciplinarity. There are new forms and new languages arise from new associations. And so what we're really doing is exploring new language. Computer now is a common medium for exploration and creativity, a communications medium that allows us to explore the known and the unknown in a new way. Because it's a dynamic processing medium, it's transformative. It can take many different, it can organize processes and data in many different ways and can take many different forms. Because of this possibility to transform data from one modality to another, it becomes a transformative instrument. Because of its possibility to reconfigure itself, it becomes a meta-instrument. Okay, I'm going to go through a bit of the history quickly. I just want to mention that, as I said, I chose architecture because I thought it combined everything. I thought it combined art and science. On the first day of architecture school, one of my professors said, "Architecture is frozen music." And I immediately thought, oh, liquid architecture, unfrozen music. And part of the education, when I was an architecture student, was to take study trips twice a year, because architecture is something you experience, it's not just something you read about. So I went to Morocco to research Moorish architecture and culture, but also for personal reasons, because, as I mentioned, I felt that I was a misfit everywhere. Part of me thought maybe this would be a place I would want to live because of the intersection of the cultures. And I kept an open journal while I was there. And that means that every time I met somebody, if they wanted to, they could draw or write in the journal so that people could represent themselves directly. But one of the people I traveled with was an African-American jazz musician and poet named Ted Jones. And one day, well, frequently, he would take out his trumpet spontaneously and just start playing in the old city in the Medina. And out of nowhere came hundreds and hundreds of people with small clay drums. And there would be this incredible music coming from all the people, and it kind of, it was a very beautiful experience. And I thought, this is really a way to transcend cultural difference and boundaries and political problems, is to play music together. And I thought, if only we could do that with images and spaces from all over the world. And I had this vision of, well, how could we do that? We could do that with satellite technology, and somehow it would have something to do with computers and 3D spaces and 2D and music and so on. I started thinking about that, trying to find a way, and this has informed my work for all these years of creating that. I wanted to perform images and spaces the way a musician performs a musical instrument. And these spaces would come off the screen and surround us. Of course, in those days, there was nothing called virtual reality. It was just something I imagined. And again, I thought there was some way of using satellite and communications technology to combine the visual languages of many cultures. And so I set about a systematic study of media and communications technology, both from a documentary standpoint and an experimental standpoint. My view is that the language of each new medium inherits the languages of previous media. And so if the media are becoming increasingly multimodal and integrated, it makes sense to study each one individually. I discovered that not all technology existed, which was a big surprise to me. So it was not just a matter of redirecting technology, but in some cases actually inventing it, which was a big surprise. So I decided to explore real-time computer animation because of the performance aspect to it. I had a hard time with computer graphics at the time, which required punch cards, and you had to wait 24 hours to find out if you had mistyped an equal sign. You know, it's just, I couldn't cope with that. So I decided to pursue signal processing, basically, real-time signal processing. And actually, I thought the combination of, well, understanding wave theory, which are, and the, well, waves are common to both sound and image, and I thought that was the language that would provide a bridge for me between sound and image. And so I pursued that in electronic music studios and in video studios. And the first thing I made, there's not much of my work that remains from those days, but here's something I made in 1973. I'm sorry, it's actually, the audio sounds terrible. I'll stop it. But it's that's all real-time live performance, and I made the music and the, although it sounds bad on this, music and the image, and I used basically what's called a common control voltage to combine a musical, what we call a musical patch, a musical process, and a visual process. And here you can, the sound, this is the use of one of the first digital processes to interpolate waveforms from one frequency to another without going through the frequencies in between. And that's actually the shape, the wave shape. Oh yeah, you can see what I'm doing. Okay, the wave shape of the sound. Anyway, and so here you can tell it's the 70s. my tie-dyed clothes. And this is at Rensselaer Polytechnic Institute in 1978, and you can see there's the image in the background. This is the video process, and the audio process is on the other side. And here's this was on the cover of Videography magazine in 1979. And I started making stereoscopic work because these things existed in a three-dimensional space. And as you might recall, I was talking about images coming off the screen as part of my original vision. Okay. So Rensselaer Polytechnic Institute is in upstate New York. And when I was there, I was working with Tom DeWitt, who was an experimental filmmaker, and Dean Winkler, who was an engineering student. And we combined electronic music, as I mentioned, video synthesis, and computer graphics. Well, one day, there was somebody watching me as I was working. He'd been watching me for about an hour. I didn't realize it. And his name was Al Barr. He was a graduate student in computer science. And he said to me, he asked questions, and we talked for a long time. And I said, well, now that I've told you what I do, can you show me what you do? So he took me over to the computer science department. He gave me a lesson in the mathematics of three-dimensional computer graphics. And again, some of the first algorithms were those he developed. But again, these were non-real-time processes, and I had a problem with it because I couldn't perform it. But that's okay. I began learning more about the 3D computer graphics that were to follow. Today, Rensselaer Polytechnic Institute has a media arts program that's interdisciplinary between music, video, and computer science. So it's nice to know that it carried on. And you just saw this piece called Voyage. And together with Tom DeWitt and Dean Winkler, we went into studios in various places, and the way we talked ourselves into these places, part of the art in those days was getting into studios because you couldn't have access to this equipment. So basically we said we were going to test the system. That was the role of the artist, was to test things. And so it was funny because the engineers ended up becoming our friends because they were interested in finding out what the possibilities were. And so we made some pieces, and they were sent to something called SIGGRAPH, which is a big computer graphics conference, the biggest one in the world. In those days, it wasn't so big. And the third time they showed our work, I thought, what is this conference? why are a bunch of engineers interested in this? And so I thought, well, I should go. And in 1982, I went to the conference and began a whole other long-term, another way of meeting people in the sciences, and especially computer science, and beginning collaborations. In 1984, or 83, I went to California. I had an opportunity to direct the computer graphics program at Art Center College of Design. But what was really unique about this opportunity, besides the fact that it was a really fine design school, is that one of the most important people in computer graphics, James Blinn, was teaching at Caltech and wanted to team teach with me. And the idea we had was that the two classes, his class at Caltech and my class at Art Center, would meet in the same time at the same place. It was just completely our doing. I don't think the administration, well, they probably knew, but they didn't seem to mind, fortunately. And so basically what happened was that we taught the opposite to the opposite. I taught drawing, visual design, and composition to the scientists, and actually I taught math and programming and Blinn software to the artists. Of course, he taught a lot more of it than I did, but I had to do quite a bit of the basic work that the students didn't know. And the concept development, of course, to both. And these are just some samples of student images from the time. Now, at the same time, I was at the Jet Propulsion Laboratory, and the first thing I did was constellation sequence for the Omnimax film, The Magic Egg, again with software by James Blinn. And I used the actual star database. This is just a calibration frame, star database from NASA, and mapped it onto a sphere along with the constellations, which were moving. And the sphere moved in, it was very simple. The sphere moved in over the dome, over out in front, and then towards you. And at the moment, the center of the dome wasn't the center of the sphere. Of course, there's a coincidence between the sphere with the constellations on it and the dome. At that moment, I dissolved out the figures of the constellations, and the stars remained, but at that moment they appeared to move from the surface of the dome to infinity. And for me, that was representing the transformation of the anthropomorphic and anthropocentric view of the solar system to our current model. And again, what interested me here was that I was putting the whole body inside the space. And lots of other things with SIGGRAPH, including, they asked me to teach a course in interdisciplinary issues in computer art and design to the computer scientists, which I did 2 years in a row. Now at Caltech, turned out Dr. Carver Mead became my sponsor. He's a professor in very large-scale integrated systems at the time. He basically paid my computer bill. And to make a long story short, when I asked him about visualization, he said that he uses visualization techniques and intuition to make conceptual leaps. And that's how he addresses the identification of research problems. But then he uses the rigor of the scientific method to prove or disprove it. It turns out many other scientists at Caltech use art to help identify new research problems. Some read poetry, some play or listen to music. And it turned out that this was sort of like a big secret. He sent one of his graduate students, Misha Mayowalt, to me because she was having a problem figuring out a research problem. And we began looking at art books, and she had this idea. She said that art is a window to perception and to the mind. And when she was looking at the work of M.C. Escher, she thought, well, maybe the eye is related, the structure of the eye is similar to this, and became interested in hexagonal packing designs and patterns, and eventually laid out photosensitive materials in a chip that, in the pattern of a of what she thought would be a kind of retina. And in fact, she received her PhD for this, for a synthetic retina. Today, this work has developed much further, of course, into a company. They may have a new company called Foveon, which creates synthetic retinas. Anyway, there are lots of other things I could talk about, but I won't carry on. So in 1985, after I had been at Caltech for about 3 months in Art Center, remember Dr. Barr? Dr. Barr from Rensselaer Polytechnic? Well, he came to Caltech. He was asked to be a professor there. So I was very happy. My friend from Rensselaer Polytechnic was now at Caltech. And so these are some of his work in mathematical modeling of three-dimensional shapes. And my work at the time involved giving up real-time movement in order to work with the rendering and modeling. And I worked with programmers in the beginning on 2D and 3D algorithms that were fundamental, just really things that you'd probably think, oh, they didn't have that. Well, things like, oh, well, it didn't have shadows, and it didn't have highlights, and they didn't think about metamorphosis, and they, there were all these things that, at least in the language of animation and visual arts, we were used to, but they still didn't have there. In fact, Jim Blintz used to say, well, he knows physics, so everything based on the physics should be correct. Well, he discovered that things didn't look right. He actually had to use his eyes to help him develop the physics. So this is some of my early work. This is called Fish and Chips. So it's basically the intersection between language, technology, and perception. You can't see that this is stereo, but it is. It's supposed to be stereoscopic. This is microfiche, lots of little fiches. I know it's an English language thing, but and this is parity bits, which is part of a computer. And okay, this is called It's Not a Bug, It's a Creature, from the cliche in English that says it's not a bug, it's a feature. So I'm sort of making fun of the language, of the jargon, in a sense, of technology, as a way of trying to reduce it as a kind of priesthood, if you will. It becomes less of a club and more of something for normal people. Okay, so I also created something called the three-ring circuit. Now, Richard Feynman, who's a great physicist, taught at Caltech. He taught a course called Potentialities and Limitations of Computing Machines. It was the last thing he taught before he died. And, well, I was actually my day job. I was teaching at California Institute of the Arts all day long and running a lab and building a program. Then at night, I would go to Caltech and I'd stay up all night and I'd do the homework for this course. And I'd take the course in the morning, sleep a few hours, and go back to Cal Arts. It wasn't easy, but it was a chance of a lifetime to study with Richard Feynman. And so I wasn't in the course for credit. I just wanted to learn. And so I thought, well, he's assigning a greatest common denominator machine. So I said, well, I'd rather make him laugh. So I thought, well, electronics is so much fun. It's a three-ring circus. Well, in English, that three-ring circus is something chaotic and crazy and fun. And so I thought, well, I'll make the three-ring circuit, again, misunderstanding the language. And so I laid out all the parts in a way that, well, was more interesting to me than just the way you're supposed to pack them together anyway. And it was interactive. And I think I succeeded in making Dr. Feynman laugh, which was my main goal. And it was exhibited at SIGGRAPH, and they didn't quite know what to do with it because, well, was it painting? What was it? It was interactive. It moved. I mean, it doesn't belong in the theater. What is it? Well, so they put it in with the paintings, but it didn't really quite fit there either. Okay, so at Cal Arts, which was my day job, I was the founding director of the Computer Animation Laboratory, and my idea was that it should be institute-wide, open to all 5 schools in the institute: film, music, art, well, that means painting and printmaking, and conceptual art, theater, and dance. And so my commitment was to interdisciplinarity as a way of making the field more intelligent and finding this, developing the space in between. I was in the experimental animation division. And again, my job, since we didn't have any applications, was to teach mathematics and programming and 2 and 3D modeling and rendering to the artists, as well as, of course, the normal things with concept development. And we wrote our own metamorphosis program. We called it Morph, which was copied by people in the industry and caught on. And now, of course, there's this famous package called Morph, but we think we named it, we think we authored the name of that. And, well, because it was in 1984, it was a long time ago. And we wrote keyframe animation software because all we had was solid modeling for industrial purposes. And that was copied by the company, which was okay with us. And so I thought, well, this is great because we're going to have independent animation throughout small studios and throughout art schools. Anyway, here's just some samples of student work from 1984 to 86. You can see the person was trying to control this shape, and it went all the wrong ways. And here's the handle on the cup, and he's trying to put it there, and it kept coming off. So anyway, I decided in '85 to have an art show that combined the work of artists and scientists at CalArts, Caltech, and JPL in order to foster communication and collaboration. It included a gallery exhibit and live multimedia performances, electronic and computer music, computer animation, video synthesis. Here I am working in the gallery, and there's actually a chip design that was quite beautiful. And here's a picture of this video studio and live performance. Well, at the same time, I was making multi-monitor installations. I won't go into a lot of detail about it, but I think concurrence. I work with simple abstraction. Well, I'll stop it. But the idea here was nature and technology, simple computer animation representing the mathematical base of computing, and the images of nature representing themselves. And there's some effects that take place with the material of the video that's out of phase by a few seconds in the inside and the outside, and the moment when they come together, it's kind of hard to explain, but the shape that cuts, this shape that cuts the background and the foreground disappears. This example doesn't really show it, but anyway, there's a professor of visual perception was talking about edge and surface detection in a lecture that I went to, and I showed him this work, and he said to me, "You're doing the same work I am, but just from the arts," which I was very touched by. Anyway, and then, oh, that's too loud. There's a piece called N loops, N for number, loops for loops, again, which combines 2D and 3D. And maybe if we can turn down the volume, I can. Can we turn down the volume a little? Thank you. Well, what it is that there are out-of-phase materials. Boy, I can't make this quick, and I'm trying. Based on the zoetrope, which is the wheel of life, and the zoetrope is basically copied, rotated a step, copied, rotated a step, copied, rotated a step, into a torus or a donut. And then when you animate them all forward, it turns out you get these waves of cycling polyrhythmic visual structures. And when I showed this piece at Princeton University, where I was teaching a few years later, it's just one of these things. It's kind of amazing. A computer science student came running down to the front of the auditorium and said, "You solved my problem." I said, "What problem? I don't know. How could I have solved your problem?" He said, "Well, I was trying to figure out how to look at multidimensional material in a single image, and you've done it." And I thought, that's great. I'm glad I have. I don't understand what I did, but I'm glad I did it. So it was wonderful. Okay. Oh, so here's what I mean when this animates. You can see that there's a cycle this way and a cycle that way. And okay. So also at the time I was developing exploring reflections in spaces and the difference between and surfaces and the possibility for new experiences in the spatial experiences in the computer that are unique to the computer. These are all stereoscopic. You're seeing them flat. But I decided to work with abstraction in this case in more gestural form, again putting in the gesture, the human gesture in creating the shapes, but really focusing on non-objective forms in order to focus on perception, because I have a problem sometimes myself when I see something that's representational. Work is hard to understand my perception, so I decided to take away what I call the objective correlative and work with abstraction. Also, again, I was interested in the musical relationships, composition, and so on. So these are some of the images. Well, it turns out that these images caught the attention of X-ray crystallographer Dr. Lynn Teneyck when I was showing my work in the San Diego Supercomputer Center. And I was invited, then he invited me to collaborate with him on a research project. These are other things I've done with scientific visualization that I'll just mention quickly. Another Omnimax film depicting the Ptolemaic and the Copernican models of the solar system that was produced for the Science Museum of Minnesota. And then in 1989, I was a course chair for Supercomputing 89 called The Artist in Scientific Visualization. And basically, it was a crash course in art history and in design and visual thinking and computer art concepts, because it's not just about artists illustrating for scientists. It's really about what happens in the common creative space that artists and scientists share, that neither could predict, that comes about only because of the communication. And so there is this aspect of illustration, which is very important, but that's part of a much bigger picture, and that's what I was trying to explain. Now, again, the Jet Propulsion Laboratory, going back, I was then asked to work on 4 missions, basically to animate the missions so that it could be used for television news and for presentations to the United States Congress to educate lawmakers and request funding. I worked on the Mars rover mission, on the Galileo, and on Mars Observer. I'll just show a little bit of the Mars Observer mission.
Electric Corporation's Astro Space Division to build the spacecraft. Weighing more than 5,000 pounds, Mars Observer was specially designed for launch aboard a Titan III rocket booster built by the Martin Marietta Astronautics Group.
Mars Observer sits atop this 12-story high field. After the Titan has placed the spacecraft into Earth orbit, a second rocket booster, the Transfer Orbit Stage from Orbital Sciences Corporation, will fire to free the spacecraft from Earth's gravity. Mars Observer will then be on its way to Mars.
Some of the spacecraft's solar panels, its dish-shaped communications antenna, and 2 booms carrying science instruments will be partially deployed right after launch.
The spacecraft will first unfold 4 of its solar panels to begin drawing solar power. Then 2 science booms will be deployed, one carrying the magnetometer, the other supporting the gamma-ray spectrometer. That's the way we'll fly to Mars. In August 1993, after 333 days in space, the spacecraft will reach Mars and enter an elliptical orbit around the planet. The flight path will be carefully adjusted over 4 months until Mars Observer is in a nearly circular orbit around the poles. At that time, all booms will be fully deployed. In other words, the spacecraft will open up like a flower.
The spacecraft will keep its scientific payload continuously pointed at Mars. 7 science instruments will spend an entire Martian year, about 687 Earth days, exploring the planet on a global scale. Weather station, Mars Observer will report on the planet's thin, hazy atmosphere and changing climate. Volcanoes and other land forms will be studied to determine the geological processes that have shaped the surface of Mars.
Could we have the PowerPoint there? Okay. Well, there are lots of funny stories about that, but and we're going to run out of time if I tell you all of them. But it was just basically one of the oddest things was that after I built the rocket and I got the spacecraft data, original spacecraft data from General Electric, oops. Uh-oh. I just knocked over some water. Basically, the spacecraft did not fit the rocket, and I thought it was my mistake. And when I called the one of the chief scientists, there were 6 of them, to explain that there was this problem, he said, "Oh, don't worry, the same thing happened in real life." I was really worried. I thought I had made a huge mistake. And then when it disappeared, later, as you probably recall, it disappeared. Didn't go into encounter of the planet. I said, I knew it. I knew there were problems with that. Okay. Oh, one last thing about that. There was about a 300-page mission plan, and as I said, there were 6 chief scientists, and it was strange because it seemed to me that I was the only one that had an overview of the whole mission, which worried me since I was just an animator. Okay, so at the San Diego Supercomputer Center, as I mentioned, the X-ray crystallographer Lynn Ten Eyck, and then Phil Mercurio, computer programmer, and I with the long hair, collaborated together to make the interactive stereoscopic animation system, primarily for use by molecular biologists. I said, I'm an artist. If I help you develop a system, I can really only make an artwork. I can't evaluate the scientific value of this. But here's basically the way it works. There's an infrared emitter on top of a TV set or on the screen that oscillates so that when it oscillates in sync with the glasses so that this image is seen by this eye and that image is seen by that eye. You wear glasses. And then the apparent position in space is here. And so that's liquid crystal glasses. Anyway, and this is the diagram of the system. As you can see, a supercomputer and real-time wireframe animation because it was over 10 years ago. And the video patch bag going into a video or data projector, one for the left eye, one for the right eye, using polarizing filters projecting onto a a screen, and then wearing these glasses, and then having a headset and a digitizing glove to interact with the human scale models, and that was very important. And, well, I have to go quickly. So the idea here was a study of molecules aided through 3D models, and the use of human-scale stereoscopic models enhances the investigation. The perceptual issues in stereoscopic visualization are the same across disciplines, and it's argued that the best person, this wasn't my argument, this was Dr. Teneyck's argument, the best person to test the perceptual qualities of such a system is an artist, one who deals professionally with perception. And he felt the synergy of art and science may yield new solutions and insights not otherwise considered or imagined. And so these, anyway, I won't go through all that. And I was interested in real-time movement, combining the language of animation with algorithmic approaches, physically based models, fluid dynamics, particle systems, and the simulation of natural phenomena. I also want to paint in 3D, leaving trails in space, making surfaces that could be altered, could be like sculpture, could be something between paint and sculpture and animation. And again, with the gesture input, we have some kind of combination of body language as part of the interaction with the other languages. And it would be for multiple people, multiple systems interacting. And again, the idea was to put the body back into a central position. And one of the programmers said it's multisensory coupling with data space. That's what the virtual reality is. And quickly I went to Princeton University after that and had a joint appointment between visual arts and computer science. And again, I was teaching the opposite to the opposite. And one of my, I should just say, what we did in computer science was very interesting. We taught from 2 points of view on the same subject. I team taught with David Dobkin, and his work is in topology. And we would ask, what is drawing? And he would say, drawing started with Bresenham's algorithm. And I would say, well, I thought it started in the cave. And we took opposing points of view just to set up a continuum of possibilities, and then we could work from there. And so what is drawing, what is space, what is time, what is movement, what is structure? And we approached it from different points of view. Well, one of the PhD students was Peter Schroeder. He's now a professor at Caltech. And one of his students, Stephen Skolny, is working on drawing and sculpting a virtual space, which is dear to my heart. And these are some of his pieces, his work. It's called Surface Drawing. And here you can see some of his images, his work. And as I say, I'm an advisor on his PhD project. Okay, well, I got tired of all this 3D stuff and decided really to focus on image processing and gesture language and working with chants and other ways of thinking outside the box. And I'm not going to show you this piece, but I started working, again, as I say, with chants. Now, in 1996, I went to something called the Mind Ship in Copenhagen, Denmark. And while I was there, it was a seminar based on order, complexity, and beauty. In 3 weeks, there were 30 artists and scientists who were in residence for 3 weeks. And what first week was based on the concept of complexity, the second on the beauty of boundaries, and the third on the biology of beauty. And the director was Tor Neurotranners. He's a philosopher of science and a science writer. And the purpose was to encourage collaboration between them and create a new way of discussion and interaction beyond the normal academic way. Well, it turns out after the first week there were big problems with communication because the biologists sat and talked with the biologists, the mathematicians sat and talked with the mathematicians, and the artists and the composers sat by themselves. So I decided to fix it. So I went around and I asked all the participants to write position statements describing their points of view on the themes of the seminar, and I wrote some additional comments. The texts were then deconstructed grammatically into semantic database structures. And then I worked with the composer, Karl-Heinz Essel, and we together developed some max patches, which is an object-oriented programming language, to process the sound and data and the text. And basically, the semantic particles were put together in new ways. So the context was constantly changing. And it was a process that was continuous. And so what you got, because it involved random operations and weighted probability, was a constantly changing meaning because of the relationships of the text was constantly changing. And what happened was, it kind of had more, it made more sense than the original material did. And I showed it, we set it up with 4 computers in a gallery on the last day because it took us 2 weeks to make the project while we were in lectures all day from 8 a.m. until 10 p.m. And then from 10 p.m. to 2 a.m. we worked on this. And it was a funny thing because some of the most important scientists came in and they thought I was just going to frame their texts and put them on the wall like paintings. Well, they didn't expect this at all. And one of them, who's an important evolutionary biologist, stood in front of one of the monitors like for 45 minutes reading everything. And I was afraid to tell him it never ends and it always changes. It doesn't have a beginning, middle, and end. So it's good. And I thought, and he's not smiling. So at the end, he walked out, and I said, well, what did you think? And he said, I liked it. I said, oh, that's good. And then outside the gallery, it was a big open room with kind of junk in the room. And they all the scientists, one by one, went out there and started running around and picking up junk objects and spontaneously making sounds and doing kind of crazy things. And there was an anthropologist watching this whole thing. And she said to me, this is amazing. I said, yeah, it is kind of amazing. She said, you should have done this earlier. I said, well, first of all, I couldn't have done this earlier. But why? And she said, well, you freed them. You made it okay to do to be free. And I thought, oh, that's interesting. So, see, that was my social work. I wanted to fix them. So there's a picture of us, and that's me. And that's the only other woman, by the way. And she was a performance artist. That's Tor. And that's the anthropologist. Okay. So here are some images from it. And you can see, by chance, some of these things. Social order is informed by biological and environmental stresses, and judging of nature is by language of the observer. Anyway, so it just combines text fragments, and we made an image fragments and movie fragments and cultural material. And here you can see it says, pointing to a borderline, is consciousness constructed from the elements of language and biology, from ideas, bodies, habitats, language, food, and drink, the various schemes. Art is a database. The advent of computer-aided studies being the result of simple dynamics. Order is a mind trip. So, I mean, it comes out like poetry, but it's really all mixed up texts that they wrote. And so things like this, such as learning from mistakes is a paradigm for learning. The more we know, the less we know. Molding the faces, thought is energy. And it is not random that there is randomness, but the relationship between the parts and the whole due to internal asymmetries of the brain and close relationships to the environment, and so on and so on. And it kind of makes sense. Okay. I don't know if I'm going to have time for all of this. Okay. The global, let's see. Oh, he taught me something here. Aha. Okay, quickly. In 1998, I got a grant to collaborate with a chemist on new display technology for computer art, and I was interested in color and light. In this case, this is about psychological color, mixing with perceptual color. That you read the text, you get an idea of color in the mind, but you also have the mixing of the perception. But the purpose of this project was to really, let's see, what can I say about? I'm afraid I'm going to run out of time, so I can't really. go through all of that. Oh, let's see. Put you there for a minute. Well, these are my test images, as I mentioned before, images that deal with color and narrative and nonlinearity. And let's see if I can go back to this. See if I think I'm out of order here. Oh, I took it out. That's what I did. Okay. That's okay. That's good. Sorry, I have to go back here. Oops. What did I do? Go. Previous. All right. Well, what we wanted to do was make flat, flexible, scalable, emissive medium that would be a new medium for artists to experiment with. And it would solve some of the problems of traditional media. And because film has a great dynamic range, but you have to be in a dark room. Cathode ray tubes emit light, but they're dim. You can't put them outside, but they do move in real time. Prints, are reflective, and you can put them outside, but they don't move, and they don't emit light. So I thought, well, we need something that emits light, flat, flexible, scalable, can be used for still and moving images. And I think I said about 3 times, I'll say it again, is that it should emit light. And so I thought the solution to this would be working with a chemist. And so the chemist is Dr. Mark Thompson, and we worked for a few years together, and we actually developed he developed luminescent dyes that actually do emit light. We succeeded in printing prints that emit light, but they're kind of dim. He's now working on perfecting that, and some of that technology will be applied to liquid crystal displays, that we're trying to push that as well. But he told me the turnaround time in chemistry for completing an application process from the research is about 7 years. So I said, okay, call me. Call me when you're ready. Okay. But anyway, those images I showed you before were part of frames of mind, which had to do with the exploration of color and light in other media, and then relating that to the new medium that we're developing. Okay, in 1996, received a 3-year grant from Intel Corporation for the Global Visual Music Project. Now remember my original vision back in Morocco. I proposed that to them, and they accepted. Actually, they asked me for 4 ideas, and they asked me if I could do 2. Malleable and transformable from any modality. You can see that it's possible to take this data and output it as pictures. In fact, you can set up a graphics process and then a musical process and then connect them. And so data coming in to it can be transformed and go out into music or image or anything else. And the author of this language is Miller Puckett. Well, Miller Puckett became a professor at UC San Diego. And so I asked him if he'd like to work on this project, and he agreed. And so this is the new user interface, which is a bit less elegant, but it combines, he calls it pure data, or PD, and that means that it considers all data the same regardless of origin. Once transferred into the computer, data from any modality is available for interaction, transformation into any other. We work together with composer Rand Steiger as a 3 co-PIs, because for us, the research process includes the creation. Our test is the creation of a piece or a work of art. And so it was very important for us to really, actually, art is research and communication. Art, and then technological art is research into the technology of communication. And so the compressed Actually, what art is a compressed research and development cycle, because you're doing a lot of the same work, a lot of this development of the technology and researching the ideas that the technology helps us explore. But then when you make a piece, you're really going into the application area. So Intel was happy with that. And we added OpenGL, basically graphics, to this environment. And we made, here's the first pictures from the first piece we made. And it was a network performance between San Diego and Thessaloniki, Greece. And George Lewis was playing trombone, Stephen Schick percussion, and these are real-time generated images that they interact with. And so the musician, the instrument, his musical instrument is extended to the visual domain, but sometimes the visual images have a logic and response of their own, separate, so that he ends up in a dialogue. But this relationship changes. It has about 13 different sections to the piece. And here's a diagram. We use 2 computers and real-time video, and anyway, you can see how there are cameras on the wrists there that they can interact with digitally, and that gets mixed in with live camera that's being processed by video mixer. It goes to the graphics computer, where it then communicates with an audio computer that's extracting and analyzing the gesture. It's actually listening to the microphone that's hearing a musician who's not in any way encumbered by the technology. It's just listening to the microphone, and the computer's extracting musical gesture. And that's one of Miller's brilliant contributions, is his ability to understand music so well that just from the sound information, he can extract meaningful musical gestural information that we can then use for interaction with the graphics. Anyway. The second piece, I decided that the content would be a shared lucid dream. It was the metaphor for distributed collaboration, nonlinear media. So, did I skip? I think I missed something. Oh yeah, I missed Maya. Well, okay. I forgot something. Well, okay. The shared lucid dream is the metaphor for distributed collaboration. It's a since this is a nonlinear interactive medium. In a way, the dream is sort of the original nonlinear narrative. And so I wanted to work with that and the idea that we're sharing a kind of dream space in the computer. And all kinds of magical things can happen in the dream. And so I want to show you a little section of that. So these musicians were improvising because they had to explore the system. So in rehearsals with them, they would improvise, and again, there are many different associations between images and music. And I tried to think of as many things outside the box as possible, unusual relationships, and that are very, very similar to the dream state. And there were two sites, two musicians at another site, then from this site, and you could hear them kind of in the background. And so they basically had databases that were, some of it was the same, some was different, had two separate sites, one in Oregon, one in New York City. And then the data that Miller's software extracted from the musical gesture was sent across the network and used to animate in real time the data at the opposite side. So they were collaborating, but they had unique performances. So that was kind of interesting. Okay, so as part of this work with the internet, I thought about something called the Internet Media Mixer, and where you could have, again, source materials from various cameras in various locations around the world, and then output them in different ways and then distribute it. And that's eventually going to come. I just haven't had time to finish it. Okay, so the thing about this that's important is the association between the images and the sounds that go beyond the normal logical associations, the relationships, that when they come together, they create something new. It's not just the one or the other stuck together. It's the relationships between them. And that's a third thing. And so I say this is 1 + 1 = 3. And the piece only exists when human beings are interacting with the computer. Otherwise, nothing happens at all. And again, the idea is that we're connecting back to the physical world and involving real people. And it's focused, actually foregrounding the musicians in a sense, because they're the ones who are the most important in the interaction with the technology, and putting the technology into the real world. So it's a physical space with an audience like you, with real musicians, and the images are only a part of it. And again, improvisation, experimentation are necessary to explore the new possibilities beyond our conscious limitations. And so the language of improvisation, which is a kind of exploration, is very important. Okay. No. Okay, I want to go now to this. Now, the same software, I use the same software for an installation piece called Morocco Memory. Oops, wrong. Forgot what I did. Here we go. Now, this is an architectural space that's sort of it's made out of wood and satin. And inside, this is big enough that you can walk into. Let's see. Wait a second. It's only one direction. I'll go back in the circle. Here we go. When you're outside, you see the light on this table that kind of focuses on these wooden boxes. And you walk inside the piece, and when you walk in and you sit down, you see that there are these boxes. And when you open one of the boxes, it's just a normal-looking wooden box. There are spices, and the spices are very aromatic. And as you open and close different boxes, of course, it mixes the different smells together. Well, this was my metaphor for the connecting of fragmentary memory in the computer, or fragments of memory in the computer. Now, these memory fragments are documentary materials and scans of my open journal that I mentioned at the beginning of my talk. It's about this period in my life that I was in Morocco, and trying to look back on that from today and see how my memory from today relates to the recorded memories at the time. But of course, today there are lots of cultural memories that have changed that. And so some of it, to be honest about the memory, I had to think about all of the things I've read and the movies I've seen, and so of course that became part of the piece, some of the memory fragments. And so The smell is kind of the link between these. It's sort of a way of accessing the memory. But every time you change the smell, of course, the memory fragments that come out of the mind are different. And so the idea was to use the technology as an associative instrument to bring out different memory fragments stored in the computer and juxtapose them and layer them and process them in a kind of a way similar to what memory does. There are 5,000 elements. I keep going around in the circle. There are 5,000 elements. I'm tired. I didn't sleep well last night. I've been very stimulated. So that's why. Okay. There are 66 basic narratives, or short text narratives, and this is just what you see on the screen would be the text, and then in the background, the whole screen is filled with dissolving images and layered with movie fragments, and the sound and the space changes. And these are just some examples of some of these narratives. And there's Ted playing in the Medina. Remember I said that he spontaneously played the trumpet. So it's kind of about all of that. But also, so it's about the mixing of personal and cultural memory. Let's see, what was I going to say about that? So it's really about freeing memory from stasis and using the computer to do that. Well, here's a little example. Can I have sound, please? Oh, how come there's that box? Oh, I wonder what that is. What is that? Oh, I see what it is. Hold on. Okay. That's one of the, let's try it again. Oh no, I did that before. Okay, see if I can outsmart it. That's better. Talk over this. The images are wall size. They're projected onto a wall-sized screen, and that makes them more of a space, right, than a surface, in a sense. But you see how they layer. And so basically it's combinatorics. There are 5,000 elements, and depending on the order of the boxes that are opened, how many boxes are open, it selects from a series of weighted probabilities to combine the elements. And of course, this is a document. I had to have the light on, so it doesn't look as good as it really does when you're in the environment, because there are colored lights that change also in response to the opening and closings of the boxes. Theoretical text that Marcia Kinder, a colleague in critical studies, prepared. She was in Morocco around the same time, and when we began talking, of course we shared our memories, and her memories became part of mine and mine part of hers, so her stories and image fragments, memory fragments are included also in this piece. Now people can get up and walk around and carry a box and lay on the floor and engage their own memory with their whole body by moving, by touching, by smelling. And most people just sat there on the stools. But some people did actually go in and lay down with the boxes. sequence of popular films. You might recognize Bertolucci's Sheltering Sky. And Matisse, who was there, and so I was inspired by the work of Matisse. And basically there are chips inside the boxes that send radio signals to remote computer that then control the mixing of the elements and the sound and the space and the light. Because the sound also changes as you interact. You probably noticed that. The more boxes that are open, the more dreamlike. And when you close them...
Whereas a toddler might not come back well.
Okay. So, and finally, I just wanted to mention a little bit about my new work. See if I can close that. Oh, okay. We've gone past that. Sanctuary, which is about cross-cultural interpretations of safe haven. Well, that came from people coming into Morocco memory. And lots of people would go in and stay there for hours. And they came out and they said, that piece is a sanctuary. And I thought, oh, maybe that's what I'm doing. Maybe I'm creating spaces where people feel somehow, I don't know, feel safe. And actually, I'm concerned about how to protect the planet and humanity and diversity in my own small way. But everything anybody can do, even if it's in a small way, I think is important. So I'm thrilled to be able to come here and have a chance to actually see the amazing both humanity and diversity of nature, and including going to the Amazon this weekend, which is it's a dream for me. But again, what I'm trying to do, it'll be architectural, but there'll be 4 screens, and instead of using boxes to interact, it will actually be using plants and organic objects. So the people will be interacting and navigating the virtual space by interacting with physical objects. And there won't be chips in the objects. Actually, what we're doing is sensing the charge, the difference in potential from touch on an object that's then sent down through that object to sensors underneath the floor of this installation. And then that will be sent by radio waves to the computer. The thing I want to mention about the last piece and this piece that's important is because there are multiple ways simultaneously to interact with the piece, it means that many people at the same time, well, more than one, up to maybe 10, can interact with the piece at the same time. And of course that changes it. So it becomes a matter of cooperation and negotiation rather than simply a single person's point of view on it. Of course, an individual can explore it, but it creates this problem of how to navigate it when you have so many ways of simultaneous input. And again, it's focused on plants and organic objects, and there'll be no wires, no obvious technology. It'll background the technology and foreground the people and the nature. My view is that ultimately, our technology is only valuable, is my view. It's really only any good if it helps us live in harmony with nature and people. Otherwise, it's kind of, from my standpoint, it's a waste of time. Or for me, I mean, that's really an urgent problem, is to try to protect our diversity, because so much of our technology is being used to isolate people and separate people and destroy the world. So I think anything anybody can do, no matter whether it's a small thing or a large thing, everything helps. And it's important to, it's really important for people to think about the consequences of what they're doing. And especially with technology, because there's such a short distance between research and application. It's changing so fast. So even if you don't think your work is going to have an impact, it's a cumulative effect. If a lot of people are working on small things having to do with war games, well, we're going to have a lot more war games. We're going to have a lot less other things. So it's crucial that people think about the ethics of what they're doing. Absolutely everything helps. Okay, well, I think I've probably said enough. I forgot to show you a piece, Maya, which I made. Should I show it or should I just stop? Show it? Okay. All right, now this piece, Maya, was done in the Supercomputer Center, where I was working with the chemists. You have to imagine that it comes off the screen, it's stereoscopic. So it comes way out into space, but I can't show you that on a flat screen today. But the pacing of the piece has to do with the perceptual phenomena that takes place when you work with stereo. That when you see things in different places, your eyes focus on that position in space. That means your eyes actually rotate and converge. So there's a muscles, your eye muscles actually work. And it takes time for your eyes to adjust. And so the pacing is based on this perceptual issue. It's kind of slow. The other thing is I'm exploring perceptual paradox. There are things that can only happen in this space. And just quickly, I'll tell you, the very first scene is hard to see in flat on the screen, but it's kind of fragmented. And it's as though you have, imagine a set of 5 mirrors, one behind the other, and they're shattered. And you have these pieces of mirror hanging in space, one behind the other, in about a space of about 2 meters depth. But each mirror is reflecting a big space from this side. So, but you know the space of these mirrors is only 2 meters, but the reflection in each one might be 15 meters or more. Well, instead of it being a reflection, what I've done is I've texture mapped. I put other stereoscopic spaces in those mirror fragments. So you look into these fragments and you see these, well, actually you see the different parts of the piece. But so you have this strange perception that you're looking into a shallow space with huge spaces in them. And that's okay. Perceptually it works because you have all the correct depth information. But I can only do that in the world of the computer. That doesn't happen anyway. All right, can we run the Betacam, please? Thank you. Thank you. Thank you. I hope that you'll have a chance to see it without those horizontal lines sometime. Those weren't part of the piece, but at least you get some idea. Oh, okay.
No. It's all right. Bom, depois dessa magnífica aula de como que a arte, a ciência e o humanismo podem ser mais do que a mera retórica, né? A combinação e o trabalho em conjunto, nós vamos abrir um espaço para perguntas. Nós vamos usar a sistemática que nós temos usado nas outras conferências do IARTE. Então, nós vamos pedir que as perguntas sejam apresentadas por escrito e daríamos um espaço inicial aí para uma ou duas perguntas orais, enquanto as pessoas podem escrever suas perguntas. Eu pediria ao professor Heitor Capuzzo para vir me ajudar aqui na organização das perguntas. Então, alguém gostaria de formular uma... Tem um... Ok. Tem um microfone. Tem um microfone aí, sem fio? Depois você passa.
Aqui?
Para ele. Mas você pode falar.
Vibeke, você fala um pouco sobre Leonardo da Vinci num de seus artigos. Eu gostaria de perguntar se é possível hoje, dentro do ambiente acadêmico, criar condições para que esses Leonardos apareçam. Eu falo porque você tem bastante experiência no diálogo entre artista e cientista. Então eu perguntaria, como é que é possível estabelecer padrões ou estabelecer métodos dentro da academia para criar uma interlocução entre arte e ciência? E, primeiramente, se isso é possível, a formação do homem, de um homem universal, um homem que possa reunir uma diversidade, compreender essa diversidade e conversar com seus colegas cientistas, artistas, e no sentido de criar uma visão mais global e humana do homem e da natureza que o cerca.
Well, that's a beautiful question. Thank you. The short answer is yes. I think you have to think so. But I really believe that if... Oh, wait, I'm getting confused by the Portuguese. I think that if people have the collective will to do that, changes will be made to enable that. I think it begins, of course, with educational structures, because that's a formal way of encouraging people to think about fields. So if the educational structures encourage that from the beginning, encourage multiple points of view, encourage art and science, and then talk about their connections, if they encourage children to do that, I think it can happen. And I really think a lot of it has to do with educational structures. People have conferences, how they establish meetings. It's every way that people learn about their field. If that can have some intervention in this way, I think it will change. But I think it has to be, I think schools and universities in particular are the most important places, but also secondary and elementary schools. It takes a lot of effort.
Não, tem uma atrás.
Hi. You talked about. I was quite blown away by the way you approach collaborative, multidisciplinary, and interdisciplinary teaching. When you talked about the lab that you founded way back when, and it was open to 5 schools, how did you cope with the huge learning curve that it was for dance students and theater students to all of a sudden start learning programming and 2D and 3D animation? Would you be able to talk about that a little bit?
Well, I can tell you what I told them. The first thing I told them, and by the way, I taught computer animation at Disney also, so that was some of the similar problems. But I start by saying computers are stupid, people are smart. Computers have to be told everything. And basically, I start with the idea that the dancer is much more intelligent than a computer, much more complicated. And that kind of puts things in perspective. And then my strategy is to ask them what is in their imagination. What would they imagine they might want to do with a computer? Or I explore their imagination a little bit. And we focus on an idea, a vision. And then once the person is inspired by their own vision, they'll learn anything. You can do math, programming. It's a means to realizing their vision. And then, of course, you go through, the programming and everything else. But only, it's a chaotic way to do it. Maybe it's not organized. But it's what we call the need-to-know approach. That each time a person needs to know, they'll learn it. And then every problem they encounter, every possibility, leads to a new learning of something new, and it unfolds. And that's always been my approach, which is not the normal way. I know, but that's how I approach it.
Okay. Hello? Okay. Vibeke Sorensen. This professor, Chico, was talking about Leonardo da Vinci. Leonardo was a painter. At the same time, he created military weapons for the princes and the kings. And okay, what I ask you is, since the beginning of our civilization, knowledge and technology has served both military and civil purposes. Mostly after Second World War, we see an increasing interface between our lives and the war technology and vice versa. Don't you think that seems to be our fate to repeat as human beings the gesture of our ancestors that in the ages of the cave paint beautiful things in the caves and at the same time smashing the other ape or man's head with a bone? Don't you think that most of the technology used today in our world comes from military purposes or goes to? Many of technology that's found in the MIT and the other institutions are used for both purposes. What do you think about this?
Oh, you put your finger on a very sensitive topic. It's what we have to work against. You're right, but that makes it that much more urgent for us to create an alternative. In fact, in my life, I've been pursued by the military at least 5 times. And now there's a big military effort in my university that is specifically targeted at my department because they want to do animation, character animation, virtual reality that's photorealistic with interactive narrative. And in fact, it's this huge thing, this huge force that's trying to transfer now what the artists have done to them. And they've even said, when they've come to ask me, well, the fate of the world hangs in your hands, which I think is ludicrous. I think it's completely, it does not hang, in the sense they mean it. What they mean is that the generals in Washington, they say, do not have as good technology as people in the entertainment industry have. And I teach in the entertainment school, USC, but my view is subversive, make it multicultural and democratic, and not monocultural. And I said, well, I don't want to make war games. I don't want our students to learn not to have empathy. And I know that's what it's about. But then they say to me, well, what if the other side gets that first? I said, well, Saddam Hussein is no more welcome in my office than the generals in Washington are. I don't think they're going to get it. Meaning that I don't care, I don't want to have anything to do with the military. It frightens me. I can understand the need at times I'm not 100%, I'm against war, but I understand if there's a Milosevic, you have to do something. If there's a Hitler, you have to do something. But in the context of an art environment, I think it's a destructive force to be teaching people to make more realistic pictures of people dying. But that's what motivated, the general question of technology related to the military has worried me for years. And that's what I mentioned at the beginning of my talk. But now, as I say, it's going the other way. The military wants the technology from us. And it's a completely reverse situation. And I think the reason is, this is my view of it. Those of you who are experts can tell me better. But the military needs a lot of this technology for communication purposes, so the general back in his safe place can know where, the men with the guns are out in the field, right? And also they need to spy and gather information and all that other stuff. Well, what artists are doing is also, they're doing research and communication, but the purpose is different. But it's still research and communication, and they want that way of communicating visually, multimodally, gesturally, because I think multimodal communication is the same across disciplines. And artists seem to be working in a way that they need their head in some ways. So I think that it's reversed in a curious way right now, but maybe that won't always last. And just last week, it makes me so nervous when I talk about it, because it makes me upset. Even last week, somebody came from a department and started talking to me about visual image perception, and I'm very interested in that, people coming from the sciences. And then one of my assistants said to me, I think it's for the military. And I said, but he didn't say so. He said, I can smell it's the military. I said, yeah, they know not to mention that word around me. Well, they hired a student. And I went to see what the student was doing, and the student was working on aircraft fighters on a naval ship. They got around me. So we have to do something to reverse it. It may be futile. I don't know, but I have to hope that it isn't. That if everybody else is doing something that brings humanity and nature into harmony, maybe they won't need the military. Maybe there won't be. But I have to think that, or there would be no. It just frightens me otherwise. I'm sorry, I can't answer it better.
Bom, nós temos várias perguntas aqui. Eu vou começar aqui com... quanto tempo foi necessário para ser criada essa última animação? Há muitas pessoas trabalhando com você nesses projetos?
Maya took about, 4 years. But that's because we had to develop the technology first. And I used the piece as a way of requesting or showing what the technology had to do. And so I had to do everything the hard way, actually, much of it the hard way. And then the programmers would give me tools that would have made it easier, but I had already made part of it the hard way. So really, the piece was used to drive the technology development. And if the technology had already existed, the piece probably would have taken me, well, if I wasn't working and teaching, it would have taken me about maybe a year or a year and a half, something like that. Because there are many layers to it. And when you're working with stereo, you actually make 2 films that are slightly different. And so so there's a huge database management problem. And that just takes a lot of time. Did that answer the question? Oh, how many people? Okay. Well, you saw in the picture there was Phil Mercurio was the programmer, and he and I worked very closely together. And then I did all of the computer animation, all of the database management, all of the recording. Harry Ammons helped me edit the video at the end, and so that's well, Lynn Tanike, the X-ray crystallographer, was involved in the conceptualization phase, and then once the technology was developed, he used it. But he wasn't really involved that much with the development, except to feedback every now and then to give his comments, and to test with some molecules and things like that. But most of the testing and development happened as a result of my work as an artist. So Lynn Tanike, Phil Mercurio, Harry Ammons, and the composer, and myself, so 5 people.
Bom, tem uma pergunta também nessa linha. Existe futuro no desenvolvimento de tecnologias para a criação de ferramentas no sentido da criação de imagens, filmes e música baseados em linguagem de programação? A interface gráfica de programação é melhor do que aquela baseada em texto?
Well, I think the object-oriented programming, for me, is better than text because, although I don't know if I should say better, it's different. Because I love text. I enjoy text. I enjoy poetry. It'd be great if we had a really nice poetry interface. But as far as the programming, when you're working with a process, we often, even in animation, we think about things as flow charts. And for me, I think about a dynamic process as things in stages, something like a storyboard or a flow chart. And so the way this object-oriented programming language works is it's like flow charts, and I can understand simultaneous things happening in time and going from one place to another. So for me, it works fine, but everyone's different. But what I've been teaching, I found actually that the animators, the artists I've worked with, they understand, especially people working with time, composers, animators, filmmakers. They don't have a problem with this. It works fine because it functions as a representation of events in time very well. And but I think traditional programming, typing in code, I think is very difficult for most artists. But as I said earlier, when someone is motivated by a vision, they'll learn almost anything, including C++.
Acho que eu vou comentar essas duas primeiro. Tem uma pergunta aqui que é um caso mais particular, mas eu posso generalizar a pergunta. Como ter acesso ao seu trabalho através da internet? E no caso particular aqui, é uma pessoa que é de Los Angeles, que está querendo saber como que pode interagir com você lá em Los Angeles. Mas eu acho que...
Virtually or physically? What did he say? Both. Oh, both. Well, it's easy. I have a website, I have email, vibeke@usc.edu, which was on the first slide. Actually, I can put that up. Oh, you have it? Read your email. Yes, only the last few days I haven't been. I've been very busy.
Artificial intelligence changed the mind-body relationship between man and machine. Como a inteligência artificial vai afetar a relação homem-máquina?
Oh, I've been kind of up all night, so I could use a machine that could help me be more logical and more that would be very helpful. what happens when computers get smart? Well, I heard a lecture recently by a researcher in San Diego who was talking about a planetary computer with planetary consciousness. And that maybe it will have some kind of life very similar to our own, that based on the definition of life, will have all the qualities of other living things. I'm not an expert in that area. I'm fascinated by it. I worry about it because what about ethics? You know, what about some kind of judgment of things that happen? I don't know how that's going to become part of it. So I don't really know what will happen when that comes about. But it definitely will change the way we communicate with people and the way we communicate with our body, because we'll be able to, it's kind of like a prosthetic, like dynamic and prosthetic devices. So we'll be able to move and do things in the tiny world and in the macroscopic world. We'll be able to scale infinitely down and infinitely up in terms of our ability to move between physical and virtual spaces. There'll be a complete fluid continuum that's possible in that world for exploration. And how we think about our relationship to other people might change, because what if we have shared identities, for instance? You know, what if one person somewhere is one of the two legs, another person somewhere else? So we have this collective, you know, creature that we're all trying to animate or become, you know, or embody somehow. I can only ask more questions, you know, but I don't really have all the answers. But this is an area I think that artists, really should get involved with, because I think artists, in a way, in my view, I think of scientists in this category too, actually, are the conscience of the culture. And so we need really to have some conscience. But there are many things that can happen. And I do think it will change. Well, one of the things I'm interested in is the dream. Because in the virtual world, there's no gravity. You have, among other things, you don't have a lot of the physical limitations that our bodies have. So what happens when you don't have, your body hasn't stopped from moving? It changes the way we think. It changes the way we think about our bodies, the way we think about space. I don't know the answers. I can just say, yes, I agree, it changes.
Ok, então nós vamos terminar. Eu queria agradecer a presença de todos, em especial a presença da professora Vibeke Sorensen, que deu essa estimulante e instigante conferência que eu acho que vai ser um marco para todos nós. Muito obrigado, então, a todos.